This is a revised video showing how to set the discrimination level for the Marina Photonics PV16 amplifier discriminator when used with the Hamamatsu hybrid photomultiplier. The top trace is the output of the Hamamatsu hybrid tube amplified by 60 dB after being split in two. The other half of the signal that's split out is going into the PV16 amplifier discriminator. We're seeing the top trace is single photon events, and the bottom trace is the output of the PV16. This is not optimum. The output of the PV16 is too wide. I'm going to turn down the gain on the PV16 by adjusting the trim pot counterclockwise. It won't take much. When the pulse width is approximately 1 nanosecond for this particular tube, one has an optimum adjustment. The high voltage is set at minus 8,000 volts and the APD is set to 400 volts. How do we know we're not getting noise? I'm going to turn off the high voltage. When I do that, there will be a burst of noise. It takes up to a minute for the high voltage power supply to bleed down and every single bit of noise to get out of the system. As you can see, the bottom trace is not triggering at all, which means that there is no false photon count output when there's no noise from the system. And it can take, like I said, a minute for the noise to quiet down. I'm going to crank up the gain on the PV16 all the way by turning the trim pot, clockwise. What I'm seeing now is the PV16 is triggering on the output of the system when there is no high voltage on the Hamamatsu tube, and therefore there can't be any single photon events. I'm going to turn down the gain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 turns counterclockwise, and I have no output false pulses. This is the first step in adjusting the threshold. The second step is to turn on the high voltage. After a while, one sees single photon events and discrimination. This sees single photon events, but the PV16 output is too wide. The threshold is still set too low, so I'm going to turn the gain down on the PV16 another half a turn. And now the pulse widths are more like 1 nanosecond wide. You can turn it down even more. If you have a lower noise system, which you would have if you don't split the signal, then the pulse width would not vary so much. You get a better signal to noise ratio when you come directly out of the tube. So you don't need to monitor the single photon output by amplifying it. You can just simply look at the PV16 output. And when the PV16 output is about 1 nanosecond for this 600 picosecond half-height pulse width nominal from the tube, you know you've got a single photon event that's adjusted optimally and you're seeing no noise. If you turn off the high voltage, as I just did, and you see no pulses, then you know you've set it at the optimum value. This is a noise addendum for the use of the PV16 Marina Photonics amplifier discriminator with the Hamamatsu hybrid tube. What you're looking at now is the top trace, as in the discrimination level set video, which is the output of the Hamamatsu hybrid tube split and amplified by 60 dB in the white top trace number 1. The bottom two traces, the blue one number 4 and the gold one number 3, are the output of the PV16 Marina Photonics amplifier discriminator. It is apparently discriminating on noise. What's going on? I have turned off the high voltage to minus 8,000 volts, and the 400 volt APD voltage for the Hamamatsu hybrid tube. The noise level is high. I'm going to turn on the 400 volt bias for just the APD. Voila! The noise has gone away. This is an important point for the adjustment of the hybrid photomultiplier noise. The APD must be biased to at least 100 volts to get the noise level down to a reasonable level. Now I turn on the 8000 volt, there's a big burst of noise, and then you see it's counting photons just fine.